The banana you ate this week is a genetic clone of every other banana on Earth, and the exact same mistake already wiped out the original banana once before, decades ago, on an almost identical scale. Most food history videos tell you how a crop conquered the world, but this is the opposite story, a warning about what happens when one single crop takes over everything. The banana you know today, the Cavendish, was not even the original commercial banana. It was an emergency replacement for a variety that got completely wiped out by disease. And right now, the exact same disease, in a new, stronger form, is spreading through banana farms across the entire world. By the end of this video, you will understand exactly how bananas became a global monoculture, why that decision is now threatening the fruit's entire future, and what scientists are racing to do about it. Let's start at the very beginning, because bananas are actually one of the oldest cultivated plants on the planet. Archaeological evidence from a place called Cook Swamp in Papua New Guinea suggests banana farming began there as early as 8,000,000 years before the present day. That timeline puts banana cultivation as early as, or possibly even earlier than, farming in the Fertile Crescent, the region traditionally credited as the birthplace of agriculture. Wild bananas originally grew across Southeast Asia and the Pacific, in the regions we now call Papua New Guinea, Indonesia, Malaysia, and the Philippines. Here is something almost nobody knows. Wild bananas are small, bitter, and packed with large hard seeds. They are basically inedible in their natural form. The banana we actually eat today came from crossing two wild species, called Musa acuminata and Musa balbisiana, over thousands of years of human selection. Most commercial bananas contain 3 sets of chromosomes instead of 2, which is exactly why they have no seeds. This genetic setup makes normal seed reproduction impossible. This means every banana plant grown today reproduces only through shoots growing from the base of the parent plant, never through seeds, a detail that matters enormously later in this story. From Southeast Asia, banana farming slowly spread west, reaching Africa through Arab traders by around 650 CE, and eventually reaching the Americas through Portuguese sailors in the 1500s. There is even a debated ancient account, recorded by the writer Theophrastus, claiming that Alexander the Great encountered bananas in India as far back as 327 BCE, though historians still argue over how reliable that particular story really is. Either way, by the time European trade routes connected the world, the banana had already traveled across 3 continents, carried along not for profit at first, but simply because people liked eating it. Now let's fast forward to the era that actually created the crisis, the industrialization of the banana trade in the late 1800s and early 1900s. When banana companies scaled up for global export, they did not choose a variety for genetic diversity or long-term safety. They chose one single variety called the Gros Michel. Gros Michel, French for Big Mike, was chosen because it tasted better, shipped better, and had a thicker peel that survived long ocean voyages far better than other varieties. People who have tasted preserved Gros Michel specimens describe it as noticeably sweeter and creamier than the banana we eat today, a genuinely superior product by most taste standards of the time, which makes its total commercial disappearance even more remarkable to consider. Here is a detail that will change how you think about banana candy forever. Artificial banana flavoring was developed and calibrated to match the taste of the Gros Michel, not the banana we actually eat now. That is exactly why banana-flavored candy tastes strange or fake to people who have only ever eaten a real Cavendish banana. The flavor was never designed to match it in the first place. 2 American companies controlled almost the entire Gros Michel trade: United Fruit Company, which later became Chiquita, and Standard Fruit Company, which later became Dole. These companies did not just control banana farms, they controlled enormous stretches of land, infrastructure, and even political influence across Central America, Colombia, and the Caribbean. This corporate power grew so extreme that it created a brand new phrase, Banana Republic, coined by writer O. Henry in 1904 to describe a country economically controlled by a single foreign company. United Fruit Company's influence was so significant that it played a direct role in Guatemala's CIA-backed coup in 1954, after Guatemala's president tried to redistribute unused company land to local farmers. The company had spent years lobbying the United States government, and once President Jacobo Arbenz moved forward with land reform that threatened its unused plantation holdings, the political machinery it had built for decades was put directly into motion against him. This single example shows just how far the consequences of a one-crop economic model can reach, stretching from a farming decision all the way to international politics and a foreign government's removal from power. By the early 1900s, The Gros Michel dominated global banana exports so completely that millions of acres worldwide were planted with genetically identical clones of one single banana variety. This is the exact mistake at the center of this entire story. A monoculture of clones shares identical genetics, which means every single plant shares the exact same vulnerabilities to disease. And that vulnerability had a name, a soil-dwelling fungus called Fusarium oxysporum cubans, which causes a disease known as Panama disease, or Fusarium wilt, a name that would go on to define the entire industry's next half-century. This fungus invades through the roots, blocks the plant's ability to move water and nutrients, and causes the entire plant to wilt, yellow, and die, sometimes within just a few weeks. Here is the truly terrifying part. Once this fungus infects soil, it can persist there for decades, even centuries, forming tough spores that survive drying, flooding, and most chemical treatments. Panama disease was first spotted in banana plantations in Australia and Central America back in the 1890s, and by the 1910s and 1920s it was spreading from plantation to plantation. The industry tried moving to new land and flooding infected fields, but nothing actually solved the underlying problem because the fungus remained permanently embedded in the soil of every field it touched. Each temporary fix bought a few more years of production, which is exactly why companies kept delaying any real investment in genetic diversity. The short-term relief always seemed to make the long-term risk feel less urgent than it actually was. Looking back, this pattern of temporary fixes instead of structural change is one of the clearest warning signs in the entire story. And it is a pattern still playing out today with the Cavendish's own slow-motion crisis. By the 1950s, Panama disease had devastated the major plantation regions of Central America and Colombia, and the Gros Michel banana was no longer commercially viable at any meaningful scale. It is important to understand this was not a sudden surprise. The collapse took roughly 40 to 50 years from the first outbreak reports, meaning the industry had decades of warning and simply chose short-term profit over genetic diversification every single time. The human cost of this decision was enormous. Entire national economies in Guatemala, Honduras, Costa Rica, and Panama had been deliberately built around exporting one single crop controlled by foreign corporations. When the Gros Michel collapsed, plantation workers, many already working in extremely poor conditions, lost their livelihoods in massive numbers almost overnight. By the mid-1950s, banana companies desperately needed a replacement, and they landed on a variety called the Cavendish, which had actually been grown quietly in English greenhouses since the early 1800s. The Cavendish gets its name from William Cavendish, the 6th Duke of Devonshire, whose head gardener grew an early specimen in the 1830s, long before anyone imagined it would feed the world. At the time, the Cavendish was considered a genuinely inferior product, smaller, thinner-skinned, bruised more easily, with a shorter shelf life, and a taste most reviewers of that era found less pleasant than the Gros Michel. This switch was never a scientific decision made from careful planning. It was a desperate emergency substitution forced by the total destruction of the previous product. And here is the part that should genuinely alarm you. The industry made the exact same catastrophic mistake all over again, planting the Cavendish globally as one single, genetically identical monoculture. Every Cavendish banana sold in every supermarket on the planet today is a genetic clone of every other Cavendish banana, all descended from the same original plant through vegetative reproduction. There are no meaningful varieties of Cavendish anywhere in the world. There is only the same plant, copied endlessly across every single plantation on Earth, estimated at over 100 billion bananas produced every single year. This makes the Cavendish the largest genetically uniform monoculture crop in all of agricultural history, an almost unbelievable concentration of risk in a single food source. The lesson from the Gros Michel disaster, genetic diversity is your only real protection against disease, was completely ignored, and history is now repeating itself in real time. The pathogen currently attacking the Cavendish is called Tropical Race 4, or TR4, a newer, more aggressive strain of the exact same fungus species that destroyed the Gros Michel decades earlier. ER4 was first identified in Taiwan back in the 1990s, and it has since spread relentlessly through China, Southeast Asia, the Middle East, Africa, and Latin America. Because the Cavendish has zero genetic resistance to TR4, this disease kills infected plants just as effectively as the original Panama disease wiped out the Gros Michel generations before it. The disease has already been confirmed in Taiwan, China, Indonesia, the Philippines, Malaysia, Australia, Jordan, Mozambique, Lebanon, Pakistan, and India, spreading across an enormous stretch of the globe. Australia's own detection back in 2015 triggered a major biosecurity response, with authorities restricting movement of soil, equipment, and plant material between farms in an effort to slow the fungus down before it could spread any further across the country. Despite these efforts, the pathogen has continued to move between regions through contaminated soil clinging to vehicles, footwear, and farming equipment, proving extremely difficult to fully contain, even with strict quarantine measures in place. The most alarming detection came in 2019, when TR4 was confirmed in Colombia, marking its first ever appearance in Latin America, the actual heartland of global Cavendish export production. Plant pathologists consider this Colombia detection to be the possible beginning of a Cavendish collapse on the exact same scale as the Gros Michel disaster decades ago. The United Nations Food and Agriculture Organization issued a formal warning in 2019 after this detection, stating clearly that TR4 poses a severe threat to global banana production as a whole, a rare and serious statement for a single fruit crop to receive from a major international body. Just like the original Panama disease, there is still no effective cure and no way to remove TR4 from infected soil, meaning any infected plantation is essentially lost for Cavendish farming permanently. Global banana exports are worth roughly $11 billion a year, and while the Cavendish makes up about 47% of all bananas grown worldwide, it represents around 99% of everything traded internationally. Economists studying this crisis have modeled scenarios where a significant collapse in Latin American banana production could push Cavendish prices in Western supermarkets up by 300 to 500% or more within a single decade. For context, Ecuador, Costa Rica, Colombia, Guatemala, and the Philippines currently rank among the largest banana exporters on Earth, meaning a serious TR4 outbreak in any one of these countries could ripple through grocery store prices worldwide almost immediately. The banana is often treated as a cheap, reliable staple fruit that will simply always be there, but the underlying agricultural reality is far more fragile than that comfortable assumption suggests. So, what are scientists actually doing to try to stop history from repeating itself a third time? One major approach is genetic engineering, and researchers at Queensland University of Technology in Australia, led by Professor James Dale, have developed a genetically modified Cavendish carrying a resistance gene borrowed from a wild banana species. Field trials of this GM banana have shown promising resistance over several years, but the path to grocery store shelves is blocked by heavy regulation and public hesitation, especially across Europe, one of the world's largest banana markets. A second approach is conventional breeding, and programs including the Honduran Foundation for Agricultural Research have produced TR4-resistant hybrids, such as one called FHIA01, nicknamed Goldfinger. The problem with breeding new bananas is speed, because the Cavendish's seedless nature means scientists must work through fertile wild relatives first, and developing a fully commercial new variety typically takes 20 to 30 years. There is also the challenge of consumer acceptance, because supermarket buyers have historically rejected banana varieties that do not visually and physically match the familiar Cavendish shoppers already expect, even when those alternative varieties are perfectly safe and nutritious to eat. A third approach involves biocontrol, using beneficial soil bacteria and fungi that compete with or suppress the TR4 fungus, alongside more careful soil management to slow the disease's spread across a region. The most fundamental solution, actually diversifying the global banana trade with many different genetic varieties, is also the hardest to achieve, because the entire supply chain, cold storage, ripening facilities, shipping containers, is built specifically around the Cavendish and nothing else. Switching even a portion of global production to a new variety would require rebuilding transportation systems, retraining farmers, and convincing supermarket buyers to stock something shoppers have never seen before, all at enormous cost. This is the quiet, unglamorous reason the industry keeps leaning on genetic engineering and faster breeding programs instead, because rebuilding the entire physical infrastructure around a genuinely diverse crop is, in practical terms, almost as hard as inventing a new global food system from scratch. Before we wrap up, here are a few genuinely surprising facts about bananas that most people never learn. Bananas are technically herbs, not trees. The tall trunk you see is actually a pseudostem made of tightly packed leaf bases, not real wood. Bananas are also mildly radioactive because of their natural potassium content, which is where the informal radiation safety term banana equivalent dose actually comes from, though the radiation level poses no real health risk whatsoever. A banana plant takes 9 to 12 months from planting to its first harvest, and after that single harvest, the main stem dies, with the plant continuing on through new shoots growing from its base. India actually produces more bananas than any other country on Earth, roughly 30 million metric tons a year. But almost none of it is exported because nearly all of it is consumed domestically within the country's own huge population. Ecuador, by contrast, produces far less total volume, but is the world's largest banana exporter, showing just how concentrated the export side of this industry really is, with a handful of countries supplying nearly all international demand. There are more than 1,000 documented banana varieties in the world, yet the global commercial market has narrowed itself down to relying almost entirely on just one. The ethylene gas bananas naturally release as they ripen is actually the same gas used industrially to ripen shipped bananas on purpose, because most bananas are picked completely green and ripened later in specialized gas-filled rooms. Even the thin fibrous string found inside a banana peel, called a phloem bundle, is one of the most concentrated sources of potassium in the entire fruit, even though most people instinctively pull it off and throw it away. Researchers have even started studying banana peel powder as a possible material for filtering heavy metals like lead and copper out of contaminated water, giving new potential value to something usually treated as pure waste. This is really the heart of the warning at the center of this whole story. Genetic diversity is nature's only real buffer against disease. A population with varied genetics will always have some individuals that resist a given pathogen. A cloned, genetically identical population offers a pathogen no such resistance at all. It simply finds an endless supply of identical, equally vulnerable hosts to infect one after another. And here is the truly unsettling part. This exact same monoculture logic has also been applied, on an even larger scale, to wheat, rice, maize, and soybeans, the actual staple foods that feed most of the human population. Scientists studying global food security warn that if the banana story ever repeated itself in one of those staple crops, the consequences would go far beyond a fruit aisle shortage, threatening food security on a genuinely global scale that would affect billions of people simultaneously. The banana is not just a story about one fruit going extinct twice. It is the clearest, most edible warning humanity has ever received about the real danger of putting all of our genetic eggs in one single basket. If stories about human choices accidentally engineering fragile systems interest you, my video on the French Bulldog covers this exact same pattern applied to dog breeding, so go watch that one next.